I play a lot of video games and regularly fiddle with tools that let me design levels for them. For my part in team-focused games, I have trouble getting a good sense of the game state. While making levels for them, I have trouble figuring out what areas need the most work. With my project, using evolving networks to record and analyze gameplay, I can solve both problems. Each video game has a set of environments that matches take place in called maps. Unlike in sports where games take place on an open field, each video game map consists of a unique set of obstacles. Moving from place to place is more prescribed. If each room is a node, we can have edges connect them via adjacency. Opening up Team Fortress 2, we can create a network that non-player characters use to traverse each map using console commands. With this network, we can begin populating with match data. At a given time step resolution, we record each node the player is in. In the end, at each time step, we have a network where node attributes represent where each player is, an evolving network. What can we expect to find with this data? As a mapper, I'm interested in cumulative metrics that we can calculate over the course of entire matches or multiple matches. For example, on the map CP Process, this building called Sewer is a good staging position for the attacking team, while being difficult for the defending team to hold or push back through. If we add up all the paths each player takes, using the direction of each edge as the sign, we can expect to see the edges in the Sewer subgraph to point in the same direction as the attacking team. However, assuming the map is fair, we should expect to see the directionality point in the other direction on these other routes. The sum over all three should be 0. This type of metric, when applied to maps in development, should give mappers a good idea of whether or not their map plays as expected and guide them to which areas need the most improvement. Other metrics that may aid map knowledge and development include finding the most traversed areas, calculating the front line at each time step, and finding which nodes see the most death. Completing this project, at least for TF2, opens up avenues to application on other more played games such as Counter-Strike, which is run on a very similar game engine. It is feasible to collect this data server-side and use it to analyze matches as they are being played. This would be useful for voice casters commentating on matches.